Hey guys, these days all the rage is about microservices this, microservices that. On many talks on the subject it's mentioned that it brings more resiliency worries because it's a massively distributed system and network operations are more expensive and error prone than in-process operations. This leads to talks about things like circuit breakers, retry strategies, and caching and other stuff like that. I'd argue this is specific to microservices as anything in a distributed system, even if not at a distributed scale as a system like this is, at some point faces this kind of problems. I wanted to get into some code about this topic because with all the talks, this is a subject that's mentioned most of the times, but seems then dropped as less relevant. So I wanted to talk about some cool libraries that help tackle these kind of problems. I'm going to start just with an example of something I faced some years ago. So imagine I use .NET Fiddle to show some simple code. Imagine we have an application that calls a network operation. Of course, in my case, it wasn't a console application, but for example's sake, so I wanted to this network operation in that specific case was very error prone, but it was something we wanted to succeed and had no problems repeating. So I wanted to retry the operation. What did I do? Well, I'm just going to copy some code here to make it faster. So I just did this kind of code with retrying while the operation didn't succeed. It's not the prettiest code. At the time, it was what I thought was the best idea. Of course, there are better solutions. Imagine I had many operations like this. I would do this code over and over again. I, I don't need to mention there are very nicer ways to do this. There are libraries to help you with this, and even if there weren't, you could just roll your own and avoid all this not so pretty code. So I'm going to talk about a library called Poly, which is a very nice library that has strategies to handle these kinds of things, like the retry, the circuit breaker, has timeout, bulkhead isolation, which I will talk also, caching, I will not talk, but nice to have, and other stuff. I recommend you come check out their GitHub that has lots of examples. I'll show you my own examples because I wanted to roll my own to get a grip of the library, but probably their examples are better than mine. This library is a bit in line with another library or framework that's probably the most acknowledged out there, which is Histrix by Netflix. Being Netflix one of the be all end all microservices sample for everyone, they have a framework for resiliency in the JVM world. As I'm more into the C# world, I'll get with Poly, but if you're into JVM, there's Histrix, and there are probably lots more libraries like this for these languages and others, pretty sure. If there aren't, here's your opportunity to make an OSS project, because it's a kind of library that it's a time saver for many people. So getting started with Poly, I have here an application. Let me check out Visual Studio Code. So I have an application where I tested out a bunch of the policies they have. I will not talk about it at all, so the video doesn't turn as large as last video. I'll probably focus on three main strategies, which will be retry, in this case n times, the circuit breaker, and the bulkhead. Just to mention three good examples, Uh, you can check out, like I said, the Poly GitHub that has lots of examples. This time I already have the code created, so I don't lose as many time creating all this. So just to provide a quick overview of the application, I have created this in this main. It's simply I have the samples in an array, so I can pass as argument the sample I want to run. They all implement abstract sample, which has some helper methods. The run is to prepare the sample according to the strategy I want to show, and the throw boomerang, it's my example that we always throw a boomerang. That means I'll provide a string to a service and I'll get back the same string. That's why the boomerang name. The service with this awesome name, like I said, receive a value and will return the same value. I will talk about the concrete implementations when showing the samples, because they are made to allow the sample to be shown. So I'll start with retry. So retry. I will show the program running later, but I guess just seeing it running won't be very explanatory. So I'll guide you through the code. So here I'm setting up the strategy. In this case, in Poly, it's called policy. On policy, we can define, you see the strategies we saw earlier: bulkhead, handle, so in case of some policies like retry depend on handling an exception. In this case, I'm handling a boomerang throw failed exception, which is thrown by the service, will be thrown by the service, and then on the handle we can use stuff like circuit breakers, fallbacks, retries, wait and retries, lots of stuff. I will just go with retry async, like you see here. And in these arguments, so the first argument is the number of retries we want, in this case 2. If in this retry count, if it's exceeded, an exception is thrown. If it's not exceeded, we don't see anything out of this code. It just fails the first time, and in the second it succeeded. All good. The second argument, it's an action on retry, so it's some code we can run whenever the retry is attempted. In this case, I'm just writing to the console, and we get the exception that made the retry happen, and the count to see in which retry we have. Imagine I had here 5. I could always log failed 1 time, failed 2 times, failed 3 times, which is nice. So in this case, I'm just printing to the console the number of this retry and what error it was. Okay, this print line is just to guide what's happening in the console, and this is the samples. So in this first, I have a method that fails after second retry. Let's check it out. So I use a service. We'll check this service to help us see the sample working. So it implements iStuff service we saw earlier. On the constructor, it receives the number of failures it it has to do before it succeeds. So in here you just, if it hasn't failed enough times, it will throw an exception, decrement the failures remaining. When it reaches 0, then it will start responding with the correct value. This helps us see the retry in action. So in this case, I configure it to fail 3 times. As we configured up here to be 2 retries, it will fail more times than the retries will be attempted. So in the last case, it will fail with the exception. We will only see one exception. It will try 3 times, but 3 times because it's the first attempt and then 2 retries. So 3 times it will fail. And then we catch the exception that in the last execution of the retry will be propagated. And to see it succeeds, here is succeed on second retry. So the policy is the same I'm using, but in this case I configured the fail service to fail only 2 times. So it will fail the first attempt, then on the first retry, and on the second retry it will succeed. That's why in this case I don't have a try catch here. So no exception will happen. I can now show you this running. In this case it's 0, so run 0. Okay, so retry 2 times policy fails after second retry. You can see throwing is what we had on the abstract sample. Let me check. So throw boomerang async, it will write throwing, then call the service. So throwing, it called the service that failed. We'll retry number 1, and the error was boomerang throw failed exception. Then another throw failed again, and the third throw, which is the second retry, then failed. In this case it will propagate the exception and failed more times than the retries can handle. Then the second method succeeds on second retry, then throwing, it will fail, the same error as always. Throwing again, fail again. Now retrying the second time, and this time thrown, because on the last one it could pass the retries. So this is the retry, much better than this code, I guess. You can centralize these policies somewhere and then use it across the board. Like I imagine using a decorator for a service that all operations can fail sometimes. So just decorate the methods with this kind of policies. Then a lot of logging to see what's going on, etc. And I guess that's it, considering the retries. So it's pretty simple, and that's what's nice using these libraries. It's not that it's very hard to implement, but someone already did it, and it did with quality. So we can use what we have already there. So retries, there are other kinds, probably better. Retry and wait seems like very nice, because if we, depending on the specific case, but imagine we want to retry but we don't want to overload the other service, so we can wait before each retry. So Yeah, there are other samples. I will not show them to avoid the video from getting too big. So I'll show you the the easy ones. Then you can check out all the rest. Uh, Poly has lots of stuff. Historics, I guess it has even more, but it's nice libraries that help these kinds of code. So the circuit breaker, that's probably the pattern that's more talked about. So what's a circuit breaker? Just to resume, circuit breaker will be a way to avoid to always be pounding on a service that's down. So we can try 1, 2, 3 times to to obtain the response, but if it fails and we don't want our services to cause a denial of service on another service, so we avoid making more calls to that service during a period of time. That's the circuit breaker. That's where the circuit breaker helps us. So we'll just check the code, and it will be pretty explanatory. So again, policy, handle, like the retries, but in this case, the circuit breaker. So the arguments in this case are the exceptions allowed before breaking. That means I'm passing 2, so it can fail 2 times. At the third time it fails, the circuit is broken. That means the next call will not be made because the circuit will be broken, as in open. So we cannot do another request to the service that's failing. Then there's a time span. It's the duration of the break. During this period, we cannot access the other service. That means even if another piece of our code will try to call this service, as long as it passes through this policy, it will not make a request because the circuit is broken and no requests go through. Imagine we have lots of requests on our side, but the other service is with problems. No calls are made, so the other service can get back up without being pounded all the time while trying to get back on his feet. Okay, then like the retry, we have some actions to see what happens. So on break, we can make something. In this case, we receive the exception that happened that made the circuit break, and the time span that will that tells us how much time it will be open. The circuit will be open or broken, if you prefer. So this span is the same that it's being passed here. But there are more advanced circuit breakers. That's probably the why there is the need to pass the span, because this could be, instead of one time span, it could be multiple time spans. So on the first time the circuit breaks, it would hold on for a second, but on the second time it will hold on for 5 seconds, and so on. So it would, as long as the service was down, we would wait a bit more for it to come up to give it more breathing time. And finally, the last action on reset, that tells us that the circuit is back open. The circuit will be back open when the first attempt after the circuit is broken succeeds. If the circuit is broken, then it's going to be repaired, but fails again, then it's broken again. In this case, when it succeeds, then the circuit is considered repaired and we get this event. So in this case, I created just a method that succeeds after first circuit break. So I'm going with a for in this case, a for until 4. So what happens is Let me just check. Okay, fail for some time service. It's another implementation of iStuff service. In this case, the first case I use the retry count. In this case, I have a failure period, which means when on construction I start a stopwatch, and only when this failure period, this time elapsed, will it be okay for this service to start responding correctly. So I'm simulating a service that is down and it's coming back up. As you can see, watch elapsed under failure period, throw exception. When not, I stop the stopwatch, no need for it to be running, and start returning the result always. So, back here, I create that service with a 1 second, so it will fail during 1 second. And as you saw, I configured the service to the policy, the circuit breaker policy, to fail after 2, to break the circuit after 2 failures. So on attempt 0, it will fail. On attempt 2, it will fail again. That's because this is pretty faster than the 1 second. On the third attempt, and this will always cause a failed execution. On the third attempt, we'll get a broken circuit exception, because we attempted 2 times. On the third time, the circuit does not allow us to try again, so in this case it will throw a broken circuit exception instead of propagating the boomerang failed. And when we get this exception, we know, in this case, no need to try again right now. It will fail, so we'll hold on for a second, because that's what we configured, 1 second of failures. And now when the 4 tries again, it will succeed, because the service is already in good shape again. So we can check out this sample running. This is circuit breaker sample number 3. So okay, so after the first circuit break, it will work like we saw. So throw. This throw is throwing the boomerang. Maybe we can confuse it with throwing the exception, but no, in this case is throwing the boomerang, failed. Then trying to throw the boomerang again, failed. Then we got here a circuit open, waiting 1 second. That's our circuit breaker on that event that I showed you here. Failed. Here it is. So in the first case, the circuit breaker didn't tell anything, just the exception was propagated. In the second time, it failed, but then it told us that the circuit is open and it's going to wait. And then we get the failed execution because the exception is propagated again. What I mean is, this is written to the console, it failed, but this exception is propagated the same, so we got this console write line. That's what's happening here. Now, okay, then in the third attempt, we got a broken circuit exception. So now we threw again, and we got an exception because the circuit is broken. This is missing the throwing because it's not even called. In this case, we try to execute this throw boomerang, but this time this is not called. This method is not called because we try to execute while the circuit is broken. So it doesn't even write the throwing because this method is not called. Broken circuit. So in this case, if you remember, when I write this, then delay 1 second, and now throwing again, thrown, and we get the message first execution after circuit break succeeded. So the circuit was good to go. If I added here a 5, it would work again because the other service is back and running. So this is circuit breaker in a nutshell. There are lots of talks about this, not very much showing the code, but talking about the pattern. So feel free to check out these other talks. Probably better explained than mine, but this is how you would implement it with Poly. Now, no, I don't want to save this. Now back to the program. I wanted to show you the bulkhead. This is newer. Most of the sample code is from last year, but in the meantime they added some new policies, and I added them here. So this is a bulkhead policy. It's simpler to set up, and it's a nice thing also to ease the pounding on other services. In this case, bulkhead, it will work basically as like a pool to access the other service. So in this case, we make bulkhead. What we're doing is max parallelization is the number of requests we can have at the same time. That means we can, using this policy, we can make the first request and the second request. The third request will go into a queue, and here we show the size of the queue. So we can make, like, imagine 4 requests. The first 2 will be executed immediately. The second 2 will be queued. So if in the meantime a 5th happens, it will fail because it cannot run immediately and it cannot wait. So created here sample of this. This time I created a slow service, so you can check out the queuing and stuff going on. So again, iStuff service. The slow service gets a time span, that is the response time. In this case, the throw boomerang will wait for the response time before returning. Now we can see here I'm using tasks. This sample is a bit weirder with tasks too, so we can see this all working. So I will run 5 tasks, so we can see the 2 getting executed and the 2 queuing and the final one failing. So 4, 0 to 5, and then I make a task run that executes on the bulkhead policy, execute a sync, and I want to do this. So I added the right line to see what task is running, and then I call the service. So the 0 and 1 will execute. 2 and 3 will be queued, and after the 0 and 1 finish, after 2 seconds, like I'm configuring here, the 2 and 3 will execute. The 5th, or the number 4, will fail because it failed. I shouldn't be using exception, I should be using this, but okay. So I waited here for 100 milliseconds, so to see the operations going on at the same time. I use the stopwatch so you can see at what times all the operations are done, to check out that 2 and 3 are actually executed 2 seconds after 0 and 1. So let's execute this. Let me just check. Bulkhead sample is number 6. So Now we have the output. So task 0 and 1 are executed with 100 milliseconds of difference, more or less. That's the wait I created there. Task 4, which is the fifth task, failed with bulkhead rejected exception because it was full. Task 2 and 3 executed roughly 2 seconds after 0 and 1, like we saw. So this is basically a pool to access a service. The configuration of this will depend on the other services. So we can, with this bulkhead policy, we can basically avoid making way too many requests to a service that it will not handle and be flooded and eventually denial of service. So it's nice to have in this kind of distributed systems. It's a new addition to Poly, new in the last month, new considering I created this code about last year, in the middle last year. So yeah, but like I said, there are other policies you can check out here on Poly. Make sure you check out all these samples, they're pretty cool. There are lots of stuff. Caching referred there, but I think this is not done yet. Yeah, it's not done yet, but I imagine it will be something like we can do on decorators. Yeah, and check this out. Check Poly if you are in the .NET world. If you're in Java world, probably Netflix Histories. If you're in other worlds, I'm pretty sure there are other libraries. And like I said, if they're not, here's your chance to create a pretty useful library. Do what you will, but don't do this code. Or do it in a central place and reuse it. Don't go around all the code with stuff like that. So, yeah. It's all for this video. Thanks for watching.